Okay, okay, let's make a start. We're as I've said in the past, we record these clinics, and they'll be available from our website for people with current support contracts. Just one more little thing before we start. I'd just like to welcome our New Zealand guests who are joining us for the first time today, and it's very good to have you along. Hope to see you more in the future. Okay, surfacing. What we're going to be talking about today is the some of the aspects of surfacing. We can only, unfortunately, touch on the surfacing module. It's quite extensive in Solid Edge, and we'll look at why do we want to do surfacing, what do we use it for, and we'll look at some of the basics that we'll be applying in some exercises, and we'll use the surface modeling to actually build some components. You can see on the screenshot here we've got a shaver body, which is an obvious candidate for surfacing. Okay, just to divide it all up, it should be fairly clear cut, but it's not necessarily all the time. We're all familiar with solid models, and here function's the primary concern. And aesthetics are an afterthought, if at all. When we're talking about surfaced components, again, I refer to the shaver body here. Aesthetics is the number one concern. How it looks, how it feels, all of those sorts of things are the primary concern, and function secondary. Now we use surfaces again where function's primary, but it happens to be using the surface technology is the easiest way to go about it. And the example I've got here is like a concrete base, drainage base, or something like that. That's it's a series of planes, tilted planes, and the easiest way to produce those and manage them is to use surfaces. And we'll look at both of these techniques as we go through. Okay, what's different about surface modeling? What is it, and how do we get into it? The key thing with surfaces is that they are characteristically they're driven by curves, and these curves are controlled by control points and polygons to apply or control the shape of these. You can see in the illustration there we've got some curves with you can see a control polygon with the red dots on it, and that's being manipulated to alter the shape of that curve. The curves are used to drive the topology, which is the overall shape and characteristic of the model. The edges you create faces from the edges, and the edges and faces in general are based on spline curves, and we'll look at what that means in a moment. As we said, shape is key, and editability, the user control over these shapes, is essential. So we must have very easy to use tools to be able to modify the surfaces, and some strict controls as well, which I won't go into today, but curvature, continuous blending, and things like that are essential to get the right effect, and I'll talk probably about that a little bit later on. When we're surfacing, we talk in terms of highlight lines and silhouettes and edges and flow lines, and these are what are important to make up the shape of the model. And that's what we use to make a shape. It sounds quite complex. It isn't. It's fairly straightforward. So we've talked a lot about curves. What are curves? So we've got the curves that we're used to, 2D lines, arcs, conics, etc. So straight lines, circles, arcs, ellipses, and so on. These are curves. We also have edges of three-dimensional shapes, so cubes, spheres, cylinders, tori, which is the plural of torus, and cones. All of these things have edges or excuse me, silhouette edges, which we can use to drive models. The spline area excuse me, have a proper cough. The spline area we mentioned a little earlier is where we have continuously changing curves, and we have a number of tools to create and edit those. And there's two types. We're looking at an example here of a 2D constructed spline, And we can have derived curves, which are derived from edges. So we might have a number of splines and edges. We also have 3D derived spline curves. An example here might be in this instance where I've got a curve that's been created between these two lines on the edge of a block. That's a 3D curve in space. There's been some points positioned on that, and then another curve generated through one of those points into the edges here, with controls on their tangencies at the ends. And that's a 3D derived spline curve. Let's just look very briefly at how to create some of these, especially the 2D curves. So starting off, I'm going to use ordered for this, and I'll be using both ordered and synchronous today. But the curve command, of course, the spline curve command is in behind the line command, and we simply click, 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 click to place points. And you'll see the crosses that lie on the curve are the points. If I reselect that curve, we will see a control polygon around the curve. And here are the points that we put in to begin with. They're the edit points. These points in between, and in between, usually between each edit point, the start point and the next edit point, we see 2 points on the control polygon. Now if we look at our command bar, we've got a number of things that we can use to edit this. To begin with, we've got a thing called local edit. Now what that does is if I change the position of, let's say, this control point, it affects the curve mainly locally, just around that edit point. It does tend to blend through the other edit points. But if I go to shape edit, the blending effect is more severe. It tries to keep the overall shape of the curve as I make the edit. So if I make changing control point or the polygon control point. Now these polygon control points, the purpose of these is that we can get them to do things that we control the rate of change of the curve, if you like. For instance, I'm going to put a horizontal vertical constraint between that control point and the end point of the curve, so that the curve vector is vertical at the start point and then blends off into the rest of the curve. I might then want, for instance, to give that more strength, raise it up, and then I might want this one to be flat, so I could have this effect. Let's change that to local edit. See the effect there. I want that to be flat, so I'll put another constraint between those two, horizontal vertical constraint from that control point to that control point. Now as I make changes in here, say to the edit point here, that condition's going to remain. I can place dimensions to these, so I could put a dimension from here to change to control that dimensionally. I could control likewise I could control the edit point dimensionally as well. So it's the edit point there to that base point there, so in X and Y and so on. So you've got complete control over how these curves are created and edited. A couple of other editing tools while we're here. We've got a thing called the curvature comb. The height of this comb shows the effect of change. So as I put more change in, we'll do a local edit here. We are doing a local edit. We'll see that control curve get bigger. I need to get rid of these dimensions to give me more control. So as I change this, you'll see that comb grow. And we also see inflection points as well. As we go through there, at the point where the curvature comb crosses over, we've got zero curvature at that point, but perfect blends through those. Okay. Just give you a brief idea on how splines work. I was talking before about the derived three-dimensional curves, and I'll show you one of those very briefly. So we're just going to create on here a rectangle. Let's make some sort of shape. Okay, so I'm now going to use from my surfacing set a key point curve. I'm going to say I want to go from the end of there to somewhere straight above the center there, right about there, to the end of here, to that vertex. And I want to edit the endpoints, so I want to change the end conditions, and the end condition I want for the start end is tangent, and tangent for that one as well. We notice that the tangency here is reversed, facing this way, so if I just pull on the tangency dot, and you can see the length of the tangency, say 252 roughly, and the other end's about, make that roughly 250 as well. So what we're doing is controlling that tangency through there. So that's a three-dimensional derived curve. We can finish that. That was a point in space I used up here. We can dynamically edit that. I can pick up that point and move it. That point might be defined by something else. I could put that point on here and so on, but that could be a point defined on a plane in space. So you can see how we've got that complex curve there. That's a derived spline. We use a function called key point curve to generate that. There's a number of other curve functions here that I'm not going to go into today, but are covered in the help and in the full training material. We do offer a course, a one-day surface training course, which will get you up and running and competent in surfacing. Okay, types of surfaces. We've talked about curves. The curves are used to create surfaces. We've got bounded surfaces, and bounded surfaces are planes that are created between curves. They can be curved, of course, because they can be tangent to adjacent faces. We've got extruded. Here's just a sketch. We've extruded that downwards to create a surface. And we've got, finally, blue surf, which I'll use a bit later on. But a blue surf is a complex surface that's highly editable. There's two functions that are unique in solid edge surfacing. It's the blue surf and the blue dot. These allow history-free flexible editing of sets of curves, families of curves that are joined together, and the surfaces resulting from those. And we'll see that in a practical example shortly. So it's probably now time to get onto an exercise. The first thing I'm going to do is this concrete drainage pan, which looks like a normal solid model, but one of the simplest ways to create it is to use surfaces. We'll then create this shaver body. Now that's quite a complex shape. There's a lot of definition in that shape. And then finally we will generate an engine cover. Now people consider surfacing is only used for those applications where you've got consumer goods like shavers and mixers and automobiles and those sorts of things. We're finding more and more that surfacing's coming into industrial goods. There's more plastic, there's more molded parts, there's more cast parts becoming more common. We're finding a lot of rotary molded plastic parts are used in industrial goods. This cover here might be a rotary molded part. So surfacing is becoming more important for everybody. So let's go back to solid edge and take a look. The first thing I'm going to do is I'm going to model this concrete base. I'm going to do this in synchronous with surfaces. So here we go. First thing's just to draw on a plane, select a plane, and draw a rectangle. I'm not particularly worried about sizes here. The exercise is not one about drawing, it's about surfacing. I'm going to create a plane on there, and I want that plane to be, use the steering wheel to move that down 20-30 millimeters below. Okay, so I want to draw a rectangle on that plane. So I need to unlock from where I am, go onto the plane. I'll just use the F3 function to lock onto that plane. I can use the sketch view or Control H to get onto the plane, and I'm simply going to draw another rectangle in here. Okay, I'm starting to build up a bit of a shape. It might become apparent to you shortly. Now I want to make a copy of this outside sketch for the top edge of the the tray-like structure I'm generating. So wait for my dots, pick up my sketch. I'm going to move that sketch up, I don't know, make a copy of it, of course, make it up say 15 millimeters. Okay, so I've got some of my my sketch in place. I'm now going to use my key point curve. Now if I draw a key point curve between 2 points, it will create a straight line. It's in 3D, so I'm taking from that point to that end point, right click to create the curve, right click to start a new curve from that point down to that point there, right click to create the curve, and so on. So pretty simple. Join the dots, you know, it's just wait for the end point to come up on each one. End point there, take that end point to that end point, and I'm just right clicking instead of coming up here and clicking the green tick. It's just I want the end point there. Just escape. Went back too far. And do what I do what I say, don't do what I do. Isn't that how that works? And one more. Okay, so we've got a little wireframe in there, and I got that one wrong, didn't I? So just replace that one. Just have a quick check of your object as you create it to make sure you've created it correctly. Not tried to rush like I do. Okay, there we go. So I've got a little wireframe of the shape that I want to produce. So this is pretty straightforward. I'm just going to now use the bounded surfaces in here and pick the edges and tick it off. I missed an edge in here, that edge, so I've got a closed loop. Preview, finish. So it's just a plain face that I've created in there. So same thing again, just go around the edges. It's not rocket science, let me tell you. It may seem a little laborious, it's really not. Putting the one on the bottom there, I can right click instead of green. Right click again, pick up this one. So it's just a matter of picking the edges there. Right click, and now we're ready to do these bits around the edge here. And one more. What I'm doing here is actually producing a set of boundaries, if you like, that will define how the solid model ultimately will go together. Now the thing we need to keep in mind while we're modeling with surfaces in Solid Edge is it does use the parasolid surface kernel to build these, so that we know that the surfaces that we're going to create are manifold. So when I click edges that are on top of the edges, they will in fact join and they will make a solid. So all I need to do now is stitch all that together. So I use my stitch command here, which says I'm just going to stitch the surfaces together, just accept the defaults and finish. Now I've got this stitch here, and seeing I'm synchronous, all I have to do is attach that model, and you want to add them together. And what that's done is created a solid model. Well, that's fine. The stuff that I don't need here, just turn off those bits and pieces. Now what we're going to do is we're going to use the thin wall command, 8mm, but I want to come outwards, so I just click on the arrow to go the other way, and I'm going to remove that face. There we go. So there's my piece of concrete. And because it's synchronous, I can modify it. Because it's a thin wall, as I bring that up, I want to tip the edges. So let's drive that up there somewhere, put a dimension on it to drive it, whatever we need to do. And of course, if we're wanting to create objects in here, we can do that quite obviously. Wait for the dots. What do I want? I want the region. I want that to go through next. So just take it down to the next, and it fits in there. If I wanted to, and this is the power of synchronous now, make other copies of that, it's pretty straightforward. I recognize that. I want to recognize a river boss. Alright. Set the action to copy, make a copy of that across here, wherever that needs to go. You notice it reshapes to get the original shape. I might want to do both of those now. So again, I can use the tools to select them. And we want to move those, copy those of course, and copy them across here. So as you can see, this makes it's a surface, it's a solid built from surfaces, but it allows us to very easily modify because it's a synchronous model. Okay, moving right along. The next one that we're going to have a look at is, as I said, this shaver body. Now this is more complex, and this is going to be driven from edge curves that define the shape. So there's a number of curves that we've got to develop. There's some 2D sketches that I've already put in place so that I don't have to reinvent the wheel, as it were. So here we go. Let's just open up what I've done ahead of time. And the first thing that I need to do is to just make sure I've got my little cheat sheet to remember what I'm doing. And I'm going to make an extruded surface off this sketch here. So an extruded surface is just I'm selecting it from the sketch, accept it. How deep do I want it to go? 12 millimeters in this case. And click. What that gives me is a surface, and a surface, as you are aware, is an ultimately thin object. They're like planes in a way. So I've got that surface shape there. Now I need to sketch on the right side, and when I'm what I'm going to do here is I'm going to produce a curve and a straight line that will create the a tangent arc here. Started off from the end of there, come down to here somewhere, and I want a little straight segment on the end of that. Okay, let's put some dimensions on this to drive him all. That needs to be 25. Okay, there we go. This needs to be tangent. I thought I'd done that, but I hadn't quite, so make that tangent to there. That's good. And then we need a couple of dimensions to drive this. So I'm going to dimension from there to the end of the arc this way, and there, and another one from there down to here. That needs to be 120. This is pretty straightforward. We know about this, and we need to be, say, 56. Okay. Now the bottom shape of this is going to be an ellipse at the end of this. At the end of the curve here, we want to place an ellipse. So I want to put a plane that's normal to the curve, so it's at right angle to the curve down the end there, right there. And we want to sketch on that plane. When I'm sketching here, I'm just going to turn it off a little bit so you can see that end of the straight line, and I want to put an ellipse on here by the center point. Now I'm going to find, notice that glyph that comes up, that's called the pierce point. That's where that curve pierces the plane, and it needs to be 18 by 15 by 0. And there we go. If you want to put the dimensions on it, by all means we can. So here's a dimensioning tool. Find the correct point. There it is. And 15. Okay, close the sketch. I will turn off the plane that I used for that because it's only confusing. So we've got that curve in there. Now we need to start generating some additional curves, and these are the 3D curves that we're going to be using to generate this part. So let's fit that, and I'm going to use now my curve. There we go. And I'm going to start from the pierce point there, where that surface pierces with the plane that I'm drawing on, and come down a little bit and create some curves. And the pierce point there. Right, so we've got that curve. I put another one in here, and it's a much simpler curve to there. Now I'm going to zoom up into here a little bit and show you what I want to do here. I'm going to take the first point of the control polygon, this point here, and make that horizontal vertical to this line. Right, so it's constrained it like that. Over here I want to make sure that this curve is tangent to that edge or face, and then down the bottom here, go back onto my drawing plane, we're going to draw some arcs, just arc by 3 points. So I'm going to go from the end of there to the midpoint on there and make that tangent. See the tangent point come up there? So that's tangent. And I want to do the same thing here. From there to the midpoint on there and pull that round so it's tangent. And we'll make the two curves tangent to each other. So two arcs tangent to each other like so, and it doesn't want to do that for some reason. They're not connected, that's why. Let me go back. Connect those arcs. So I want to connect the end of the arc to the end of that arc and then make them tangent. This end gets cut off, so it doesn't really matter that much, but it does affect this shape. We saw that shape change in there. I'll use my control polygon to not do that, to undo that. I will just take that tangency off there, that's alright. So shallow that curve out a little bit. This one here, now we want to modify that to put a thumb bump in here. That sounds a bit funny, but what I'm talking about here is to have a little bump shape for this. There's a switch goes in here, so I'm going to pull that out like so, push it in like so. So that's a bit exaggerated at the moment. We'll push that out a little bit like so, but we want to have that little pronounced bump in here, so I might pull that up to there. So we've got that little bump area in here, and that's pretty good for what I want at the moment. That's looking okay. Yep, I might actually fiddle with these curves a bit. Just take that point on out and just connect those to each other and make them tangent. So the end of that to the end of that, and see if the tangency doesn't muck it up too much. No, that's better. Okay, that's fine. That'll do for what I want. I think, yeah, I want to put a point on there anyway, so I need to put a point on that curve. This for something else I'm going to do a bit later on. So just on the intersection point there of those two. It's just a start point for the next object that I'm going to do. Okay, so we've got our guide curves in there. They're fairly complicated, and we're going to use that point, this curve, and this triangular curve to create a blue surf, and then use these as the guide edges. So let's do that. So we go to surfacing. We're going to create a blue surface. We'll start from there, go to there, and then to there. And what you see there is it's like a loft. It's taken those direct points. Now that's good. That's the cross section step. I want to go to the guide curve step. I'm going to select single because I want to pick that curve and that curve, tick it off, and you see we've taken that shape in, and then we take this curve and this curve, and the curve didn't fit. I've made a small error there. Let me fix that. Let's see what I've done. Go back to that sketch. Okay, that will probably do. Take that off. See if I can get that round a little bit further. I just want to put the center of that round onto there roughly. Okay, that's good. That will do for what I want to do. Okay. Close the sketch. Let's go back to my blue surf. Right, so picking that point. That's better. Okay, next line, make sure we select single here because I just want to pick up that curve and that curve, check it off, and then that curve and that curve to pull the other side in. And now we'll see we've got this quite nice shape. Now the interesting thing is when we produce that shape, let's go one further. I'm going to close it off so we have a we can produce a solid here just by closing this off. And now when we stitch this, you'll see another option come up. So just select everything, and it says it's going to result in a solid body. Is that what you want? We say yes. Now if we edit this curve, come back here, dynamically edit the curve. Let's just change that point slightly. You see the model update in real time. So we've got a lot of control over how this is going to look. And with surfacing, it's what looks good is what's good. So we've got the outlines of our shaver body. We've got some cutouts we can do on this, but time prevents me from going too much further. You can see how we get this fairly complex shape out of some fairly simple curves very quickly. We could have defined other curves up the side here, mirrored those across, and had a great deal more control. So you can see that it's not a complex operation. Finally, we'll do the last one. We're going to do an engine cover. Now this engine cover is going to be built in situ. So we have an assembly. Go to a configuration here that I'd have for the engine cover. This one. And I've partially modeled this. We've got a block in here, so I need to find that, and we're going to in-place edit or in-place activate to edit that. First thing I'm going to do is just pull that up 100 millimeters. I've made it fit roughly in the shape, but it's nowhere near where we need it to be yet. But let's get rid of the rest of the model. We're going to do we're going to sketch. I'm going to go to ordered. So I transition to ordered. Notice we've now got synchronous and ordered in the one part. So I want to sketch on that face, and I'm going to produce a curve. Right, again as we've done before. So we do this a couple of times now, so it's getting familiar. So we're going to start off about here somewhere. I'm going to produce it off the top of this face here, so like so, and ramp it right down here somewhere. Okay, running out of room, usually with me, so I need to edit that curve a little bit. It looks a bit ugly, so we'll pull that out a bit more curvature in there, a bit longer. Yep, that's about roughly what I want. Now, that's fine. I want to put another curve on here now. I'm just going to use an arc to produce it. So we're going to sketch again, but this time I want to be offset, so parallel plane from the base coordinates here, that, and back say 300 millimeters. Now in this case I'm going to just draw an arc by 3 points. Out here somewhere, here, and just keep those two edges together. I want to join, just make sure it's centered, so I'll take the center of the arc and put it onto the plane there somewhere. That's fine. Now to create surfaces, our curves have to be joined, and if I look at this, you'll notice that those curves don't touch, so I need to make them touch, and we have a function unique to Solid Edge called blue dot, which allows us to edit curves to put them together, to place them together. One thing I forgot to do, which was the point of this, so go back to that sketch, edit the profile of the sketch. Talking too fast, you see. One thing that we need to do in the draw command is convert to curves. So I'm taking an analytic, which is an arc, and I'm converting it to a spline. So click on that, you'll see it's a spline. I've got the control polygon around it. Okay, now back to my blue dot. What I need to do is to join this curve to this curve, least amount of movement. What it's put in there is a blue dot, which is an edit point between those two. It doesn't appear in the history, it's only to do with the curves. So now we're ready to make a surface through here. So we're going to use that curve, tick it off. We're going to use this is the cross curve, tick that off, and it produces a surface through there. Now I want to put that surface on the top face, so I use the replace face function, select the top face, tick that off, replace it with the surface, finish. So we've seen it create that surface now. Okay, we need to do just one or two things to clean this up a little bit. I want to put some rounds on very quickly, just on the corners here and here. Make them 23, I think is what I want. And then I want to put a round along this edge, make that 20. Okay, so now we need to thin wall all of this. So I'm going to thin wall. Common thickness is that. Pick the faces to remove those. Check it off, preview. And we've got a nice beginnings of a cover here. Now I want to control this cover. Remember I'm in ordered, but I can just go straight to home, put a dimension from here to here, and wherever I want to put that, I want to put that down there somewhere. And we need to modify that dimension, so you should be able to see that update on the screen. There we go. The webinar makes it a little slow. I want to make that 350. So you can see that you can see that we've got all our synchronous editing commands right here. So we've got a hybrid mode where we've got both ordered and synchronous together, and if I roll that in, you can see I can change that in a synchronous manner. The surface informational updates, everything works as we'd expect. I'll make that 2 degrees, and likewise with this one here I'll bring that in 2 degrees as well, so you can see the effect of that. Pull that into 2 degrees. Okay, let's show our the rest of our assembly, and we're starting to get close to what we want here, but I need to be able to edit this a little bit. I want to change some shape in here a little bit, so I'm going to come in here and I'm going to pick up that blue dot, right, and I'm going to dynamically edit it, and a little gnomon comes up. Now this is allows me to edit this. I can do a delta edit, an absolute edit. What I can move along a vector, or I can restrict myself to plane. I'm going to restrict myself to the center plane here, and I'm going to do a shape edit on both of these. So the overall shape will change. And you see as I move that, this solid is being updated with the surface here. I'll move that up to there. I want the little dent to be more up there and up that way. So there's a bit of hand clearance under there. Now, we also want to make some changes to the curve to dynamically edit that. And I'm going to do a local edit here just to pull this down so that I've got a little reverse dump thing in there. That's pretty ugly, isn't it? Who wanted that? Who wanted that? There we go. I'll pull it up that way, pull the curve in. As you can see, I can dynamically edit from the context of the assembly, quite straightforward. Finally, one of the things I might want to do is to just do a synchronous edit to this back face here and lean that out. So I want to lean that out, say minus 18 degrees. And let's return to our top level assembly, and we've got our little part. So you can see editing in the context of an assembly using surfaces, everything works as expected, and we've got a lot of power. And you can see, you saw in that example that we're using both synchronous and ordered together. The surface was ordered, the rest of the thing was synchronous. We could edit the synchronous and synchronous, the ordered and ordered. We didn't really worry about where we were, what we had to do. So in summary, just briefly, if you look at, just work through some of these fairly simple procedures, you'll become pretty proficient in surface modeling. If you want to accelerate that process, we run a one-day surface modeling training course. And if you want to find out more about that, contact your business development manager, either Barry, Lee, or of course John in Melbourne. Okay, we're coming to the end here. We've got a Q&A session now. I see there is a question here. Me saying, how do you create the solid from the stitched feature? In ordered, it'll do that automatically. If the stitched feature is manifold, in other words, all the faces, it forms a closed box, if you like. It will give you a prompt saying, do you want to make it a solid? If it's in synchronous mode, all we do is when we do the stitch, we right-click on the stitch and use the attach command, which attaches it to itself, which is a solid. So, and we get the question is asked: do we want to add material or remove material? Of course, the answer is add material, which was the default. That's what we did last time. So, if you got any questions, yeah, I know that everybody understood this completely, so it's there shouldn't be too many. It's all fairly simple stuff. So. While you're thinking about your questions, I'll move on. I'm watching the questions thing here, and you're all being very quiet. Is everybody awake? Here we go. Can you go back? Can you go back control pivots? I'm not sure what that means. Can you go back control point pivots? Previous. Yes. In the ordered mode, where you're doing surfaces, all your control points are there all the time. As you saw in that last exercise, you can edit those. You can edit the control points. You can edit the edit points, which are the original creation points. Everything's fully editable, yes. Yes, you can add control points after a curve's created. You can also, and as I said, I was only going to touch on it now, you can also add curves to a blue surface after you've created it. So you can intersect it with a plane or another body and create those curves of intersection, which are also editable. It's Blue Surface, very, very powerful tool. Very powerful tool indeed. So next time, we're well into December, 2 weeks away. It'll be a bit of a wrap-up session, and that will be the last one for the year. So and don't forget to get your fix before the end of the year. We'll be starting these again in January, of course, and I'll have more information on that next time. But as I said at the beginning, we record these, and the videos will be available on the website. So if you need any more information, have a look there. Don't seem to see any more questions coming in. I've obviously completely bamboozled everybody, I can tell that. So it remains for me to thank you for your attention. I've run a little bit over time here. I like to keep these under 40 minutes if I can. 35-40 minutes is what I want as a maximum. But I like the subject, so I do get a bit carried away. Surfacing, as I said, just to reiterate, surfacing is not just for consumer goods or high presentation goods. Surfacing has use in just about all disciplines. Wherever you're making components, it might be cast, it might be moulded. You'll find a lot of stuff these days is becoming rotary moulded because it's quite an efficient way of making things. You need surface modelling to be able to create those parts effectively. You can do a certain amount of it without surface modelling, but it can make it easier. And you saw with the concrete, that makes it very good. There doesn't seem to be any more questions. I'll wrap up and say thank you. Thank you, James. Good seeing you on board. Good seeing you all. It's been a good turnout. And I will see you next time. Thank you, one and all.